Hello my dear students, welcome you to this lecture 4 of the chapter Kinetic Theory of Gases. In this lecture, we are going to discuss the problems based on our previous lecture, that is lecture number 3. Okay, so let's move on to our first question. The first question is, a vessel is filled with a gas at a pressure of 76 centimeter of mercury at a certain temperature. The mass of the gas is increased by 50% by introducing more gas in the vessel at the same temperature. Okay. The resultant pressure of the gas is. So that's the question. Here the question is to find the resultant pressure if we increase the mass. Okay. So what is the equation for pressure? What is the equation for pressure? We know the pressure is given by 1 by 3 nmVrms square, isn't it? Where your small m is the number density, which is equal to number of molecule per unit volume. So let's substitute this here. We get it as 1 by 3 nm by V into Vrms square. Okay. Now, small m is the mass of a single molecule. Okay. And capital N is the number of molecule. So when you multiply m into n, you will get the total mass of the molecule, that is capital M. Okay. So your pressure equation becomes 1 by 3 capital M by V into Vrms square. Okay. Now, in this process, the temperature remains constant, is it? So, the temperature remains constant. Temperature remains constant. Also, what about the volume? We know that the volume of a gas is considered to be the volume of the container in which the gas is taken. So, here we does not change the container, isn't it? So, container before addition of mass, container after addition of mass is same. Hence, the volume should remain the constant. Okay. So, temperature is constant, volume is also constant, isn't it? So, can we say that the pressure is proportional to the mass from this equation? That is, P is equal to 1 by 3 m by V into Vrms square, where Vrms square remains constant since the temperature does not change. Okay, and volume already remains constant, so that pressure is directly proportional to the mass. So, if mass increase by 50%, then pressure also increase by 50%, isn't it? So, what is the resultant pressure? The resultant pressure P is going to be the initial pressure P1 plus 50% of the initial pressure P1. So, what is your answer? Your answer will be 76 plus, what is 50%? Half, right? Half of 76. So that is 76 plus, what is the half of 76? In 7 it is 3 times, correct? That is 38, isn't it? So 76 plus 38, what will be your answer? Your answer will be 6 plus 8 is 4. Okay. Then 1, 10, 11. Yes. So this is 114 centimeter of Hg. So that is the answer. 114 centimeter of Hg is your answer. Okay, so this is a very simple question. We have to use the equation of pressure. Okay, that's all. Now, we will move on to the next question. The next question is, the molecules of a given mass of a gas have root mean square speed of 100 meter per second at 27 degrees Celsius and 1 atm pressure. What will be the root mean square speeds of the molecules of the gas at 127 degrees Celsius and 2 atm pressure? So that's the question. Now, going ahead, let's write the given data. What is the given data? VRMS1 is 100 meter per second. Temperature T1 is 27 degrees Celsius. We have to write it in SI, that is Kelvin. Okay. So 27 plus 273, that is equal to 300 Kelvin. Alright. Now, what about the pressure P1? The pressure P1 is 1 atm. Okay. Now, what about the rest of the data? The rest of the data is VRMS2. That is what we have to find, right? Okay. Now, what about the temperature T2? 127 degrees Celsius. So, in Kelvin, it will be 127 plus 273, which is equal to 400 Kelvin. Okay. And pressure P2 is 2 atm. Okay. Let's see how to do it. Okay. So, what is the equation of VRMS? We know VRMS is equal to square root of 3RT by capital M. Isn't it? So, R is universal gas constant, which is constant. 3 is a constant. Here, what about the mass? The mass of the gas is also constant because they have already told the molecules of a given mass. So, mass is fixed. So, we can say that the VRMS is proportional to square root of the temperature. Right? So, VRMS 1 by VRMS 2 is equal to square root of T1 by square root of T2. Isn't it? So, what is going to be the answer? So, it is going to be VRMS 1 is 100 divided by VRMS 2 is equal to square root of 300 by 400, which is equal to square root 3 by 2. Isn't it? So that your VRMS 2 is equal to 100 into 2 divided by root 3, which is equal to 200 by root 3 meter per second. So that's the answer. 200 by root 3 meter per second. So this is a very simple question. If you know the formula of root mean square speed, then you can easily find the answer. Okay. Now let's move on to the next question. Here is the question. Two molecules of a gas have speed 9 into 10 raised to 6 meter per second and 1 into 10 raised to 6 meter per second respectively. What is the root mean square speed of these molecules? So that is the question. Okay. So in this question, there is two molecules. Their speed is already given. Then how will you get the root mean square speed? Yes. From the definition, right? VRMS ms is equal to square root of v1 square plus v2 square plus v3 square plus etc. plus vn square all divided by capital N. Do you remember that formula? So here we have just two molecules, so we need v1 square plus v2 square divided by 2. Okay, so you do it yourself. Directly they have given v1 v2 and there is equation with you now. So you substitute it, find the final answer and put it in the comment box. See you all in the next lecture. Bye bye.